Good morning, everyone. Welcome to Ashok IT. My name is Ashok. Before going to start the session, please confirm, is my voice audible for everyone? Is my voice audible for everyone? Please confirm in the chat box. People who joined in the Zoom. Please respond in the chat box. Yes. All right. Good morning, guys. So today we are here to discuss about Docker and Kubernetes. So nowadays, this Docker and Kubernetes is having lot of demand in the market, not only for DevOps engineers, even developers also should know what is this Docker and what is Kubernetes, how to work with this Docker, how to work with the Kubernetes in our application development, and how this Docker and Kubernetes is helping both developers and DevOps engineers to simplify application deployment process. So developers will write the code. That application should be deployed into some server. Here, instead of doing all the setup manually, we can automate that and we can manage that easily by using this Docker and Kubernetes. Now, so here first let me give you the high level information about what is Docker. So Docker is a containerization platform. So it is used to package our application code plus dependencies. Here, in order to run our application, we will develop some code, and for that application, along with the code, some dependencies also required. Like, I mean, the dependency is nothing but, so if suppose the application is developed by using Java, we need to install Java software to run that application, and we need a database to run this application, and we need a server to run this application. Those are called as dependencies which are required to run our code. So whenever you develop the application, to run that application, you need to do that setup in the machine, install operating system, install Java, install database, install server, then deploy the application. Instead of you are doing that dependencies setup manually, Docker is going to set up all the infrastructure that is required to execute our application. So application code plus application dependencies will be packaged, and we are going to run that package as a Docker container. So as Docker is a packaging application code and application dependencies, we are calling Docker as containerization platform. We are going to create a container. Container is going to run our application. So Docker containers are created. Then why we need Kubernetes? So here Kubernetes is not the replacement for the Docker, guys. Don't think that, sir, if I know Docker, do I need to learn the Kubernetes? If I know the Kubernetes, do I need to learn the Docker? So here, Kubernetes is not the replacement for Docker. Kubernetes is called as orchestration platform. Docker is a containerization platform. Kubernetes is an orchestration platform. Sir, containerization means packaging our application dependencies to execute in any machine. Packaging application code and application dependencies to execute in any machine. So that is called containerization. Then Kubernetes is orchestration platform. It is used to manage containers, creating the containers, updating the containers, scaling the containers, destroying the containers, recreating the containers. Whatever the Docker containers we are creating to run our application, those Docker containers management can be done by using Kubernetes. That is the first difference between Docker and Kubernetes. Docker is called as containerization platform, which is used to package application code and application dependencies. So here in the real time, creating the containers manually, updating the containers, recreating the containers, scaling the containers, scale up the containers, scale down the containers. That is difficult process. We need somebody to manage our Docker containers to run our application. That somebody is Kubernetes. Kubernetes is called as orchestration tool. Docker is called as containerization tool. What is the meaning of orchestration? Orchestration nothing but management. It is a process which is used to manage our containers. Are you guys getting the primary information related to Docker and Kubernetes? Docker is a containerization software. Kubernetes is orchestration software. Containerization means packaging our application code and application dependencies. Kubernetes is orchestration platform which is used to manage the containers. So as part of this workshop, so these 2 days, today and tomorrow, we are going to learn only Docker. Almost we are going to spend 10 to 12 hours to understand what is Docker. Now, sir, as part of the Docker, what we are going to learn? First, we need to understand what is our application stack. So as part of the Docker, we are going to understand first introduction related to application stack. So when we are developing an application in the real time, what are the components will be available, or what are the technologies that we are going to use in our application stack. Then life without Docker. If we are not using Docker, how our life will be as a developer, as a DevOps engineer. Life without Docker, then life with Docker. If I use Docker, then what is the advantage? If I don't use Docker, what are the challenges? How the life of a DevOps engineer, or how the life of a developer when the Docker is not available in the project and when the Docker is available in the project. Then we will see Docker introduction. So what is Docker and what are the advantages of the Docker? Docker introduction we are going to understand. Then next, we are going to see Docker architecture, how this Docker is going to work, what all the components are, what all the things that we need to know to work with Docker. If I want to keep Docker in my resume, what are the things that we should know? What are the things that we should know to keep Docker in our resume? Docker architecture and Docker installation, how to set up Docker. Here, I'm going to set up Docker in Linux virtual machine. I will take Linux virtual machine in the AWS cloud. In that machine, I'm going to set up the Docker installation, then Docker commands. Docker commands we are going to understand. Then, so 15 to 20 commands will be available. So when we are working with Docker, so we need to know those Docker commands. Then next one, the most important part in the Docker, that is Docker file. So in order to create a Docker container for our application, we need to write the Docker file. Docker file contains some instructions to create the Docker image for our application, how to work with Docker file. Then next, we are going to discuss Docker network, then Docker volumes, how to create Docker volumes and how to use the Docker volumes. Then next, Docker compose, how to create multi-container based application. My backend application will be executed as one container and my database will be executed as one container. How to establish the link between our application and the database. Multi-container based applications we are going to set up by using Docker compose. After the Docker compose, the last part in the Docker, that is Docker swarm. Docker Swarm. Docker Swarm is also one of the orchestration platform only, guys, but Docker Swarm does not have much advantages. So here, instead of Docker Swarm in the industry, people are using Kubernetes. Kubernetes is alternative for Docker Swarm. Kubernetes is a replacement for Docker Swarm. So here, up to here, we are going to learn about the Docker. Here, last part in our Docker workshop is Docker Swarm. Docker Swarm is orchestration platform. What is orchestration platform? It is used to manage our containers. Here, but Docker Swarm does not have much features when compared with the Kubernetes. Docker Swarm does not have many features and Docker Swarm does not have auto scaling capability. So that's why in the real time, For production grade applications, Docker Swarm is not recommended. As an alternate for the Docker Swarm, people are using Kubernetes. As an alternate for the Docker Swarm, people are using Kubernetes. Kubernetes is orchestration platform. It is used to manage the containers. How to create the containers? To create the containers, we are using Docker. To create the containers, we are using Docker. Docker and Docker Swarm both are not same. Docker and Docker Swarm both are not same. Docker is a containerization platform. Docker Swarm is orchestration platform. The replacement for the Docker Swarm is Kubernetes. So this is the agenda for this 2 days workshop. As part of this 2 days workshop, we are going to learn application stack, life without Docker, life with Docker, Docker introduction, Docker architecture, Docker installation, Docker commands, Docker file, Docker network, Docker volumes, Docker compose, and Docker swarm. So once this Docker workshop is completed, then in the next week, we are going to discuss about Kubernetes. Now, as part of the Kubernetes, we need to understand a lot of stuff, guys. Kubernetes is very important nowadays. Docker, Kubernetes, both are very important. So we will understand first Docker Swarm versus Kubernetes. What are the differences between Docker Swarm and Kubernetes? Kubernetes is also called as K8S. Between this K and S, there are 8 characters available. So that's why people will call it as K8S, nothing but Kubernetes. Docker Swarm versus Kubernetes, Kubernetes introduction, Kubernetes setup, or Kubernetes architecture we need to understand. Kubernetes architecture, then Kubernetes terminology, then Kubernetes setup. Here, first we are going to understand how to set up Kubernetes cluster, self-managed cluster. That means we are going to manage this cluster, self-managed cluster. Then after, we are going to discuss Kubernetes provider managed cluster, EKS. We are going to understand Elastic Kubernetes service provided by AWS Cloud. It is managed cluster, provider managed cluster. AWS will give you the cluster to run your Docker based applications. EKS is commercial. If you don't want to go for that EKS, then you need to go for self-managed cluster. By taking Linux virtual machines, we can create that. Next, we will discuss about pods, namespaces in the Kubernetes, and pods in the Kubernetes, pod lifecycle in the Kubernetes, pod lifecycle in the Kubernetes. Next one, we are going to understand services, Kubernetes services. There are 3 types of services available in the Kubernetes: cluster IP, node port, and a load balancer. There are 3 services available in Kubernetes. Then next one, after the services, we need to understand replication controller, and a replica set. Replication controller, replication set. Then we will understand daemon set, and stateful set. Next one, we will discuss about deployment in the Kubernetes. This is most important concept, deployment. So in the deployment, there are several strategies are available. Deployment strategies are available. One is recreate strategy. Another one is rolling update strategy. And in the real time, our projects will be deployed to the production by using blue-green methodology. So what is that blue-green deployment also? We are going to understand as part of deployment. After that, we will discuss about config map and secrets. Config map and secrets we are going to discuss in the Kubernetes. After this config map and secrets topic is completed, then we will discuss about Kubernetes volumes, which is used to store the data permanently. After Kubernetes volumes are completed, then we will talk about applications deployment in the Kubernetes cluster. Applications deployment. Before applications deployment, we need to talk about one more concept called Helm charts. How to work with the Helm charts in the Kubernetes, and Kubernetes monitoring tools. Kubernetes monitoring tools. So as part of this monitoring tools, we are going to discuss Grafana and Prometheus. Grafana, Prometheus, and next one, ELK stack. As part of this ELK stack, we are going to understand Elasticsearch, Logstash or FileBeat, then Kibana. So this ELK stack is used for application log monitoring. Kubernetes monitoring tools, Grafana, Prometheus, ELK stack. So ELK is the combination of three products, guys: Elasticsearch, Logstash, and Kibana. In place of Logstash, you can use FileBeat also. This stack is used for application log monitoring. Grafana and Prometheus to monitor our Kubernetes cluster. Helm charts, these are package managers for the Kubernetes cluster. Kubernetes volumes to store the data permanently. Config map and secrets are used to configure environment properties. We will never hard code our database properties, application messages within the application to externalize configuration properties of our application. For example, database properties. To manage the database properties based on environment, we are going to use this config maps and secrets. Deployment, this is the most important concept. This is the concept we are using in the real time to deploy our applications into Kubernetes cluster. The deployment also having several strategies. Deployment recreate strategy available. Deployment rolling update is available. And mostly applications will be deployed into production with zero downtime by using blue-green deployment, blue-green methodology. Blue-green is not related to Kubernetes, guys, but this is one of the most famous methodology which is used in the industry to deploy applications into Kubernetes cluster. Already my application running in the production. For example, already my application running in the production, I want to deploy latest code into production without stopping the existing application. That's where we are going to use blue-green methodology. So in the Facebook application, you have seen lot of updates. So every month or every 2 months, new functionality is adding to the Facebook, but the Facebook server is never down. It's never, there is zero downtime for the Facebook. So when the application is running, how they are deploying the latest code into the application? So we can also do that by using blue-green methodology. Blue-green is one of the deployment methodology. For the DevOps people, this is most important interview question. How your application is deployed into production with zero downtime. My existing project should not stop. My existing server should not stop, but my latest code should be deployed into production without stopping the existing server, without stopping the existing application. With zero downtime, we can deploy latest code into production. For that, we will use blue-green methodology. That also we are going to understand. Daemon set and stateful set, replication controller and replica set. Services will be available in the Kubernetes, cluster IP, node port, and load balancer. Pod lifecycle. So pod is the smallest building block in the Kubernetes to run our application. Namespaces will be available. Namespaces are like our packages in the Java. And EKS is a paid service in the AWS cloud. EKS is used to create managed Kubernetes cluster. So EKS means ready-made Kubernetes cluster they will provide. You can run your application directly on the EKS, but EKS is not free. EKS is paid service. If you don't want to go for paid service in the AWS, then you can take Linux virtual machine and we can set up that cluster. So if we set up the cluster on our own, then that is called as self-managed cluster. If you use AWS cluster, then you will go for EKS. Next, Kubernetes architecture, how application deployment will happen in the Kubernetes, what are the components are involved in the Kubernetes, that we'll discuss in the architecture. Introduction, Swarm versus Kubernetes. Swarm is outdated in the market, guys. There is no demand for the Swarm. People will not use the Swarm in the real time for production deployments. We are using Kubernetes. So there are some differences between Docker Swarm and Kubernetes we are going to learn. So this is our Kubernetes content. So Kubernetes is most important and little difficult also. We need to understand that very clearly and we need to practice that. Kubernetes is little difficult and a little confusing as well. Docker is easy. So as part of the Docker, we are going to understand this stuff. So this is the agenda of our Dockers and Kubernetes course. This is the outline of our course. Application stack, life without Docker, life with Docker, Docker introduction part, Docker architecture, Docker installation, Docker commands, Docker file, Docker network, Docker volumes, Docker compose, and Docker swarm. Are you guys clear with this point? Are you guys clear with this point? What we are going to learn as part of this course? Are you guys clear with this point? What we are going to learn as part of this course? All right, fine. Now guys, so as we discussed, so here this class, this weekend we are going to learn Docker and Kubernetes. Docker, only Docker we are going to learn this weekend. This weekend means 01 October and 02 October. So today and tomorrow we are going to learn the Docker. Evening also we have the Docker session. So timings for the Docker. So it started at 8:15 a.m. From 8:15 a.m. the class will be there till 11 a.m. Then this is a morning slot, and evening the class will start at 7 p.m. 7 p.m. to 9:30 p.m. class will be available today's evening. Today's evening. Okay. So tomorrow also mostly the timings will be same. Today and tomorrow class timings for the Docker. After Docker is completed, then we will start our Kubernetes. After Docker is completed, then we are going to start the Kubernetes concepts. Are you clear with this plan? This weekend, this Saturday and Sunday, today and tomorrow, we are going to spend for only Docker. Almost 10 to 12 hours we are going to work with only Docker. Timings, so morning session 8:15 a.m. to 11 a.m., 7 p.m. to 9:30 p.m. in the evening. So class timings, if any changes in the tomorrow, I will update that. Tomorrow also we have a class, and class notes will be provided. Class notes will be provided. I have already prepared a material for the Docker. Complete step-by-step document is prepared. So how to work with Docker and what are the commands we need to use to work with the Docker, how to write the Docker file, everything in detail. The document is prepared. So by using this document, you can practice. So today, after first session is completed, I will upload this document. So in our portal, you guys can get this Docker notes. By using this Docker notes, you can understand how to work with this Docker. Up to Docker Swarm. Up to Docker Swarm, we have this material. All right. So till Docker Swarm, the material is ready. All the concepts that are targeted in the Docker as part of our material. Similarly, for Kubernetes also, material is available. Okay, guys. Perfect. Shall we get started now? I hope you are good with the information related to our class and what is the syllabus of our Dockers and Kubernetes. Yep, it is a paid course, guys. The people who want to attend Dockers and Kubernetes, it is a paid course. The course fees is 5,000 for both Dockers and Kubernetes. Class notes will be provided and recorded videos also you are going to get. The people who want to attend only Dockers and Kubernetes, it is paid. It is paid. The 5,000 is the course fees for both Dockers and Kubernetes. All right, let's get started with our session. Now, guys, as I told you, we are going to understand introduction for Docker. So here, whenever we are talking about any application, our application will have 3 layers. Our application will have 3 layers. Any project, if you take, 3 layers will be available for our application. So here, front end will be available for a project, and backend will be available for a project, and database will be available for a project. So application stack, front end stack will be available. Front end stack will be available for our application, and backend stack will be available for our application. Front end stack, backend stack will be available, and a database also will be available for our application. Now, front end stack, some people will use Angular, or some people will use React.js to develop front end of the project nowadays. Either Angular framework or React.js library people are using to develop front end part of the application. Either Angular JS or React library people are using to develop front end part. Similarly, so along with the front end, we are going to have a back end also for our application. Backend application contains the core business logic. So this backend application people will develop by using different technologies. Assume that people will use Java to develop a backend, or people will use .NET to develop a backend. Some people will use Python also to develop a backend. So these are backend technologies available in the market. So many technologies are available, but I have given very few here. Next one, some people will use Oracle database for the project. Some people will use MySQL database. Some people will use MongoDB. Depends on the project requirement. They will use this technology stack. Front end stack will be available, back end stack will be available, and database stack will be available to develop one project. By integrating all these things, we can prepare one project to run. So client has given the requirement, client is having a business. For the client business, he need one application. So for that application, front end and back end required. Front end means the user interface. Whatever we see on the website, that is called user interface. The buttons, the logos, the menus, whatever the content you are seeing on the website, that content is called as front end. Whatever you are seeing on the website, that content is called as front end of the website. So to develop the front end of the website, there are several technologies available. Okay, so if you open our institute website, you can see some logo is there, some button is available, images are available, and menu is available. When you click on this menu, some data is displaying. Whatever the operation you do on this website, that is called as front end user interface of our website. To develop that user interface, people are using Angular or React.js along with the HTML, CSS, and JavaScript. So web technologies will be available to develop front end of our project. When user performs some operation on the front end, that means I'm clicking on online training. When I click on online training, some table is displaying with some data, with some link, some button, name, timing, date, course names are displaying. So that means when you perform some operation on the front end, then front end will talk to back end of the project. So in this back end, the business logic will be available. For the project, business logic will be available in the backend. So some code will be available in the backend. That code will execute to perform the operation. Whatever the action user is doing, for that action, code will execute in the backend. The business logic will be available in the backend. So when you perform some operation in the front end, request will go to backend. Backend will contain business logic. That business logic will communicate with database. So data storing. So data store. Database is called as a data store. Our information will be stored into database. For every application, database is required to persist the data. Persist nothing but storing permanently. Now, if you see here, when you click on any course, here, if you click on Python full stack, you can see you are getting some duration, you are getting some price. You are getting some duration, you are getting some price. If you go to other course, now the duration is coming, the price is coming. So this data coming from database. For my application, a database is available. In that database, data is stored. When you click on online training, so some courses which we are providing through online, the course schedule, the timetable we are displaying here. All this data available in database of my project. So for every project, user interface will be available, business logic will be available, database will be available. Database is used to store the data. Without a database, we cannot manage our applications. For every application, this database is mandatory. So there are several databases available in the market. Oracle is one database, MySQL is one database, MongoDB is one database. Oracle is one database, MySQL is one database, MongoDB is one database. Right. So it depends on the requirement. We will use any one database for our project. Nowadays, in the market, microservices are trending. As part of the microservices projects, one project will have multiple databases also, depends on the requirement. So MySQL database, Oracle database, MySQL database, MongoDB, Oracle DB, and MongoDB. In my project, two databases are there. We are using Oracle as a relational database, and we are using MongoDB as a NoSQL database. Depends on the project requirement, multiple databases also will be available. So database is used to store the data. There are several databases available in the market. Depends upon the project requirement, we are going to use database for our project. Next one, for every project, business logic will be available. That business logic, end user cannot see that. End user cannot see that business logic. So when you perform some operation, then that business logic is going to execute. So that business logic is called as backend of our application. End user cannot see that business logic, but when end user performs some operation, that business logic is going to execute. Business logic of the application. In order to develop that business logic, there are some technologies available in the market. Java is the most famous technology for developing backend of the applications. Java is having lot of demand in the market. 3 billion projects running on the Java in the IT industry. Lot of demand is there for Java for backend development. Along with Java, there are some other technologies also available to develop backend of the website. So Java, .NET, Python, PHP, Node.js, like that there are several technologies are available in the market which are used to develop backend part of our project. Backend nothing but business logic will be available. Right. Next up. So end user cannot see the backend part of our project. End user can see only front end part of our project. Front end nothing but user interface. Whatever is visible on the website, whatever you can see on this website with your eyes, that is called user interface, which is called as front end. To develop this front end, there are several technologies are available. Angular and React. Along with these things, for web pages, we will use HTML and CSS, and we will use JavaScript and Bootstrap. JavaScript and Bootstrap also will be used in the front-end development. So this is called technology stack of a software project. User interface will be available, business logic will be available, database will be available. Are you guys clear with what is application stack? Are you guys clear with what is this application stack? Guys, are you able to understand what is the application stack? What is the front end? What is the back end? And what is the database? Yes, good. Fine, guys. Now, in order to develop this application, our project management team will decide what are the technologies we need to use, which technology we need to use at the front end, which technology we need to use at the back end, which database we need to use for our project. That will be decided by our project architect team. Our project architecture team will decide technology stack. Fine. Based on this technology stack decided by our project management team, our developers are going to write the code. For a project, multiple developers will be available. A set of development team will be available for our project. Development team will be available for our project based on the project requirement. So based on the technology stack of the project, this development team is going to write the code for the project. This development team is going to write the code for the project. That code they are going to store into GitHub repository. For every project, a repository will be available where the project code will be integrated. So developers are working in different locations. Some people are working from office, some people are working from home, some people are working in Hyderabad location, some people are working in Bangalore location. Within one team, multiple developers will be available. These people are called as dev team members. It is a dev team. These dev team members, this person will work on login functionality. This person work on registration functionality. You see, in our website, there are several functionalities are available. Front end available, back end available for our application. So development team is working on the project. Multiple developers are there. they will work on different functionalities in the project. All the developers code should be integrated at one place. All the developers code should be integrated at one place. So to integrate all the developers code at one place, we are using GitHub repository. We are using GitHub repository. It is a version control software. We can integrate all the developers code at one place, and we can monitor who is making what change in our project, who is doing, who is implementing which functionality, when this code implemented, when this code modified, who modified, when modified, why modified, what modified. All the changes we can track. All the changes which are happening in our source code, we can track by using this GitHub repository. So developers completed the coding, developers kept their code into GitHub repository. Once the developers kept the code in the GitHub repository, can we directly deliver this project to the client? That is my question. Development is completed, coding is completed, development team has done the functionality, they have written the code, all the code they kept in the GitHub repository. Once the code is available in the GitHub repository, can we directly deliver this project to the client? Can we do this? Can we do this? Deliver? Can I deliver the project, guys? Code is available now. Code is done by developers. Code is available in the GitHub repository. From the GitHub, can I take the code and can I deliver that code to the client? Can I deliver that code to the client? Why? Why we should not deliver? After coding completed, directly can we deliver that code to the client? No, no. Once the coding is completed, we cannot deliver that code to the client directly because we need to perform testing. We need to perform testing. So once the coding is completed, directly we will not deliver that code to the client. We need to perform several testings. We need to perform testing, thorough testing we need to perform on the code. That a testing is used to verify application functionality is working as expected by the client or not. We have to test it. Whatever the code we have done, whatever the code developers has done, that code is working as expected by the client or not, we have to test it. Now, in order to test the functionality of our project in the real time, we are going to use several environments. Developers will test our code. For the developers testing, there will be one environment called dev environment. So our developers has done the code, developers code is available in the GitHub. So once the code is, my code is working in my system, your code is working in your system, but your code and my code is integrated in the GitHub. After integration, is my code working? Is your code working? Is the project is working or not? That we need to test it. So developers also responsible to test the code of our application. So for developers to test all the code at one place in the company, we will use one environment called dev environment. So environment nothing but a platform which is used to run our application. Environment nothing but a platform, a machine. In that machine required softwares, a database, a server, everything will be set up. Everything will be set up. The environment that we are preparing, the platform that we are preparing to run our application is called as one environment. So for developers, we need to provide one environment to test the application code. Developers will write the code and the developers will test the code also. For developers to test the code, we need to prepare one environment called dev environment. That means we need to take one remote machine in the cloud, in the AWS cloud. We are going to take one remote machine. In that machine, we will install the required front-end technologies, required back-end technologies, database setup, everything we will configure. Then we will deploy our application in the dev environment. So when we deploy the application in the dev environment, developers can test that application. If any issues available, then developer will fix that issue. So dev environment is used by developers to test integrated code. So every developer will write the code in their laptop. They will test it. If it is working, then only they will store into GitHub. So in the GitHub, every developer code will be available. code integration will happen in the GitHub. When the code is integrated in the GitHub, is that code working as expected or not? We have to test it. To test that all the developers code, dev environment will be used in the companies. So once the developer testing is completed, now we are going to give that code to testing team. For every project, how the development team is available, similarly, testing team also will be available. We need to give our code for the testers to test it. For testing purpose, for software testers to test our application, we will create one more environment called SIT environment. That is also called as a SIT environment. SIT stands for System Integration Testing. So here, developers' mindset will be different, testers' mindset will be different. Being a developer, always will think in the positive scenarios, but testers will think in the negative scenarios. So that's why developers will test the application, tester also will test the application. To test the application, for developers testing, we will, as a DevOps engineer, we will prepare dev environment. We will create virtual machine. In that machine, we will install the softwares and we will configure the servers. We will configure the database. We will deploy the application. That a dev environment will be used by developers for a testing. That is called dev testing. Developers will test it. Developer testing will be available for our project. Here, testers testing, SIT, integration testing. That means complete application functionality will be tested by software testers. That is a SIT environment. So our developers will test it and our testers also will test it. Once our SIT testing is completed, then we will give the project to the client to test it. That is called user acceptance testing. This user acceptance testing will done by client or client side team. Client testing will happen on the project because client is the owner of this project. Client has given the requirements and we have developed this project. We have tested from our side. We are saying that all the functionalities are working as expected, but client also should feel that everything is working. So now simple man, when you are going to purchase a bike or car, so directly you will go to showroom, pay the money and bring the car to your house, or you will go for a test drive. When you want to purchase a car with 10 lakhs, when you want to purchase a car with 10 lakhs or 15 lakhs, so go to showroom, pay the 10 lakhs, take the car keys and come to your home along with the car. Or before paying the money, you will do a test drive. Will you do the test drive or not? For the bike or for the cars, we will go for test drive to see how that car is working. So similarly, when the client is going to take the project from the company, client also will do the testing to check all the functionalities are working as expected or not. Client is also going to check all the functionalities are working as expected or not. For that, client will do the testing. That testing is called as UAT. For testing purpose, for the client testing purpose, we need to prepare one environment. For a testers, our company testers testing purpose, we need to prepare SIT environment. For a developers testing purpose, we need to prepare dev environment. Dev environment, SIT environment, and UAT environment. After client testing is completed in the company, there will be one more environment which is called pre-prod environment. That means pre-production. Before giving the project to the production deployment, we are going to test our project in the pre-prod. Pre-prod testing nothing but live data testing. We will use the live data to test our application. When developers are testing, when testers are testing, when the client is testing, we will use some dummy data and we will test our application. So here in the pre-production environment, pre-prod environment, that means that is just before the production. In the pre-prod, our application will be tested with live data. So here application performance testing and application servers with load balancing testing, live data testing, database load testing, performance testing, stress testing will happen for our project in the pre-prod environment. Once the pre-prod testing is successful, finally our project will go for production, prod environment. Prod environment is nothing but live environment. Prod environment is nothing but live environment. Once the application is deployed in the production, then end users can access our application. So once we do production deployment, that means our project is released for the public access. Now we are able to access Facebook. That means Facebook is available in the production. We are able to access Gmail. That means Gmail is available in the production. We are able to access Naukri. It is in the production. Every application that you are accessing through internet, nothing but it is production grade application, production environment application. So once the developer has done the coding, directly that code will not be delivered to the production. Directly that code will not be delivered to the client. We need to perform several testings. We need to perform testing on the application. So testing is happening at only one place. Is the testing is happening at only one place? The testing will not happen at only one place. So testing will happen in the dev environment. In the dev environment, developers are going to do the testing. And once the developer testing is completed, that code will go to sit environment. That code should go to sit environment. In the sit environment, our testing team, software testing team will do the testing. The sit testing is called as system integration testing. Once the sit testing is completed, that code will go to UAT environment. Client testing will happen. Client side team will be there to perform UAT. Guys, in some companies, development will done by one. For some projects, development will done by one company, testing will done by other company. Client will give the development for one company, testing will be given for other company to get the quality. So have you hear a company name called Value Labs? Value Labs is pure testing based company. So Value Labs company will test the projects which are developed by other companies. So development will done in one company, testing will be done in other company. That client will take a decision on that. So if other company doing the testing, that is called UAT. Instead of client is a businessman, he will be busy with his business work. So client will give the testing for other company. Development will done by one company, testing will done by other company. So that is called UAT, user acceptance testing. Once the UAT is completed, then if user is accepted, okay, whatever the functionality I have expected, everything is working. I am good. I'm satisfied with your project development. Let's go for production. In the UAT, client will decide go or no go. Go means project development testing is successful, go for production. Go means green signal. No go means हमारा बैंड बजाएगा. No go means issues are there in the project. It is not good for production. It is not accepted for production. Client is not accepting our project for the production. If client found some issues in the project, if some bugs are available in the project, then client will reject our project in the UAT by saying no go. No go means we are gone. Our work is having some issues. So when we are working with our project development, always we need to try for go. Go means whatever the work we have done, client accepted our work, client liked our work, client agreed for the production deployment. That is go situation. So when we get a mail from the client saying that no go, our project development is failure. Our testing is failure. Functionality is not working as expected by the client. When the client say no go, client will not release the budget. Client is not satisfied with our work. So these situations will be there in the project. Sometimes we will get go, sometimes we'll get no go if client is not satisfied. If we get go, then that is a celebration for the development and testing team in the company. Our company will give the party also when the client says that go. That means whatever the work we have done for last 3 months of time or last 6 months of time, that work is accepted by the client. That is go. That is a celebration movement. Company will give the party also. If it is no go, आपका लग जाएगी आपको. If it is no go, that means there are some issues in the code. So then developers and testers should work hardly to fix the issues, and we need to give the project for the UAT testing. Client should accept it, then only we will go for live environment. Once it is go, then we will go for pre-prod environment, that is just before the production. How the project is going to run in the production, the same kind of environment we are going to simulate in the pre-prod. In the pre-prod, our project will be tested with live data, our project performance will be tested, and our project load balancing will be tested. Our complete application behavior, infrastructure testing we are going to do in the pre-production environment. Once the pre-production environment, once the performance and everything is stable, if the load balancers are stable, then from the pre-prod, application will be moved to prod environment. Prod environment means live environment. Public users can access our application. www.facebook.com. That means you are hitting production environment application. So this dev environment, sit environment, and UAT environment, pre-prod environment are called as non-production environments. Whatever the environments that we are having, these environments are called as non-prod environments. Okay, so these environments are called as non-prod environments, and this prod is called as prod environment. So when we are working in the company as a DevOps engineer, or as a developer, or as a tester, we need to understand that code is completed, developers has done the code is integrated in the GitHub. That code will not go to client directly, that code should be tested. The testing will happen in non-prod environments. The code will happen in non-prod environments. In companies, there will be two types of DevOps teams. One DevOps team will manage non-prod environment deployments. One DevOps team will manage prod environment. So the DevOps team, which is responsible to release our project into production, that team is called as release team. The team which is responsible to release our project into production environment, that is called as release team. Release team is responsible for production environment. Production environment means setting up all the infrastructure, setting up all the softwares which are required for the project. That team is responsible. Non-prod environments and prod environment. Guys, what is the difference between non-prod environment and prod environment? Can you guys tell me? Can you guys tell me what is the difference between non-prod environment and prod environment? Please respond in the chat box. Please respond in the chat box. What is the difference between non-prod environment and prod environment? Did you get my point? What is the difference between non-prod environment and prod environment? Non-prod environments nothing but our internal environments which we are using for a testing purpose. That's it. Non-prod environments are nothing but the environments which we are using for a testing purpose. These are called as our internal environments. These are called as our internal environments. Prod environment nothing but it is a live environment where we are going to deploy our application. Are you able to understand what is environment and what are environments will be available in the real time? Environment nothing but a platform which is used to run our application. Environment nothing but a platform which is used to run our application. Non-prod environments will be available and prod environment will be available. For every project, one prod environment will be available, several non-prod environments will be available. Non-prod environment nothing but those are testing environments to test application behavior. Prod environment means it is live environment where the project is deployed for public access. As a DevOps team DevOps team is responsible to manage all these environments required for our project. So developers are responsible to develop the code, integrate the code, test the code. That's it. Developers will be available up to this stage only. Developers will be involved up to this stage only. Developers will write the code, developers will integrate the code, developers will test the code, and in the dev environment. So DevOps team is responsible to prepare the environment, to deploy the application. If any issue comes in the code, then developers will fix it. Developers will be there to fix the issue in the code. But DevOps team is responsible to prepare all these environments. Guys, what is the meaning of environment? Nothing but the systems that are required, the softwares that are required, the database that is required, everything we need to configure to run our application. So now my code is available in the GitHub. In order to run this code, I need to install Angular. I need to install Angular in a machine, and I need to install Java 1.8 version in the machine, and I need to install Tomcat 9.5 version in the machine, and I need to install MySQL database in the machine. So my project is having front end, my project is having back end, my project is having a database. In order to run this application, we need to prepare the environment. Environment, nothing but setting up the machine with required softwares to run our application. As I told you, here our application will have front end, our application will have back end, application will have database. In order to run this application, front end components should be installed, back end components should be installed in the computer, and the database also should be installed in the computer. So that is called our infrastructure setup and configurations management. Infrastructure setup and configurations management we need to do as a DevOps engineer. Now, in order to run my project in the dev environment, I need to install Angular in that computer. I need to take one computer for the dev environment. That can be a physical computer or that can be a virtual machine. So nowadays, mostly we are going for cloud. So if we go for AWS, in the AWS, we can create one virtual machine. In that virtual machine, I need to install Angular for front-end component execution. I need to install Java for backend execution. The Java project should be deployed in the server. For that, I'm taking a Tomcat server. For my project, I need a database. The database I'm using MySQL or MongoDB or Oracle, anything depends on the project. Now we need to install all these softwares in the machine. Along with that, I need to take my code. Code is available in the GitHub, and these are dependencies to run my code. Application code plus application dependencies. Code is available in the GitHub. To run this code, I need Angular installation. I need Java software. I need Angular software. I need Java software. I need a Tomcat server. I need a database. Then only I can run my code. Then only I can run my code. Are you guys getting my point? Are you able to understand what is the code and what are the dependencies to run the code? Code will done by developers. Code will done by developers. Developers will write the code. That code will be available in the GitHub repository. In order to run that, can I directly now? I will give you my GitHub repository. In my GitHub repository, there are several projects available. My GitHub repository, there are several projects available. So this is my GitHub repository. If I give this GitHub repository for you, can you directly run this project? Can you directly run this project in any computer? Directly, can you run this project in any computer, guys? Can you directly run this code in any computer? I will give you my code. I'm a developer. I have done the coding. My code is available in the GitHub. If I give this GitHub repository URL, can you directly run this project? You are not from the development background. You are a DevOps engineer. I am a developer. You are a DevOps engineer. I will give you my code in the GitHub. I will give you GitHub repository. You can download also. After downloading, what you need to do? You cannot run that code directly because my project is developed by using Java. So in order to run this code, first you need to install Java. To run this Java web application, you need a Tomcat. My project is having a database connections. You need to install MySQL. That is called environment preparation. That is called environment setup. As a DevOps engineer, you are responsible to set up the environment which is required for project execution. Now, in the company, do we have one environment for a project, or we have several environments for the project? Only one environment is available, or we have several environments for the project? Several environments are required for the project testing purpose. Dev environment will be available, sit environment will be available, UAT environment will be available, pre-prod will be available, prod will be available. So in all, for every environment, I will take virtual machines. In the cloud, for a dev, I will take dev machines. Linux machines I will take for dev environment. For sit environment, I will take some other Linux machines. For UAT, I will take some machines. For pre-prod, I will take some machines. For prod, I will take some machines. In all the machines, I need to install all these dependencies. In every machine, I need to install Angular. I need to install Java. I need to install Tomcat. I need to install MySQL. Then only my project can run. In this dev environment, I have to install this. In the sit environment, I have to install. In the UAT, I have to install. In the pre-prod, in the prod, everywhere I need to install all these dependencies. Then only my code can run. Then only my project can run. Now tell me, installing these softwares, preparing this environment in all the computers, is it easy? Is it easy? Guys, is it easy? No. Tomorrow, client told that he need one more environment called staging environment. After UAT, he want one more environment called staging environment. Then again, we need to prepare the environment. We need to install all the softwares, Angular, Java, Tomcat, MySQL, Git, Maven. So many things we need to install in every machine. So this installation, this environment preparation, making sure our application is executing is difficult and time-taking process. Now, for example, in the sit environment, I have few machines. In the sit environment machines, already Java 1.7 available. My application needs Java 1.8. There will be some version compatibility also. So managing the dependencies, managing the environments, managing the softwares which are required to run our application is difficult. Are you able to understand what are the challenges that we are going to face in the real time for the project? Whatever the code developers are doing, that code will not go to the client directly. That code should be tested several times. To test that code, several environments we are going to prepare. Developers should test it. For that, dev environment will prepare. Testers should test it. For that, we will prepare sit environment. And client should test it. For that, we are preparing UAT environment. Pre-production testing should be done for our project. For that, pre-prod test will be available. After pre-prod is successful, then code will go to live environment. Live environment is nothing but production environment. Okay, code is available, environments available. Then what are the challenges we are going to face in this process? Can you guys identify what kind of challenges will come? Can you guys identify what kind of challenges will come? Come on. Can you guys identify what kind of challenges will come? Challenges will come with the dependencies. Challenges will come with the dependencies. Now, in the sit environment, Java 1.7 is available. In the dev environment, Java 1.8 available. In the sit environment, Java 1.7 available. The code which is working in the dev environment, same code not working in the sit environment because of version conflict. Because of version conflict. In the dev environment machine, in the dev environment computer, Java 1.8 version installed. In the sit environment, Java 1.7 installed. Java 1.7 installed. The code which is working in the dev environment, the same code is not working in the sit environment. These kind of problems are very common in the industry. The code which is working in one environment, the same code, the same functionality is not working in the other environment. Are you guys able to understand? The code which is working in one environment, the same code is not working in the other environment. The dependencies which are working in one environment, the dependencies which are not compatible with other environment. So the dependencies conflicts we will get. The dependencies, the environmental problems we are going to get. So to overcome these problems, to overcome these dependencies problems, we are going for Docker. So if you don't use the Docker, then in every environment, you need to install all the required front-end components, all the required back-end components, and the database components also in the project. If you are using Docker, then you no need to set up these dependencies. All these things will be taken care by Docker. You no need to take care of any dependencies which are required to run your project if you use Docker. If you don't use Docker, then as a DevOps engineer, you are responsible to set up the environment to run the application. Environment setup nothing but taking the machines, installing the softwares which are required, managing the dependencies, managing the versions. Everything is your responsibility. Developers will not involve in the environment setup. Developers will involve in only writing the code. That code will be available in the GitHub. As a DevOps engineer, it is your responsibility to prepare the all environments, to set up all the technology stack to run your project. Then you need to deploy that project. So in the dev machine, Java 1.8 is available. In sit machine, Java 1.7 is available. The project which is working in the dev environment, same project is not working in the sit environment because of Java version compatibility. Our project requires Java 1.8, but in the sit machine, Java 1.7 is available. So there is a problem. Version problems are there. All these kind of version problems we can resolve by using Docker containers. When you go for a Docker, you no need to bother about the dependencies. You just tell to Docker what is required to run your project. Docker will prepare that environment. Docker will prepare that platform to run your project. That's why Docker is called containerization platform. That Docker will package your application code, your application dependencies. Once you prepare the Docker container, that Docker container you can run in any computer without bothering about the platform, because the platform will be taken care by Docker to run your application. Are you guys getting my point? So life without Docker, it is horrible nowadays. Life without Docker is horrible because lot of dependencies we have to manage, not only in one environment. Application may have 10 environments in the real time. In all the 10 environments, you need to manage that setup. That is difficult. If you go for a Docker, Docker will take care of it. Now, do you understand why Docker is having lot of demand? You just write the code, Docker will take care of the environment. Using the Docker, you can run your application in any computer without bothering about versions, without bothering about the environment. Are you guys getting my point? Are you guys getting my point? So what is the advantage of going for a Docker? What is the advantage of going for a Docker? Come on, guys. What is the advantage of going for a Docker? What is the advantage of going for a Docker? Come on. Deployment process, environment setup process, dependencies management will become easy when we go for Docker. To test, build, and deploy, we are going to use Docker. To test, build, and deploy, we are using Docker. If you don't have a Docker in your project, if you don't use Docker in your project, if you don't use Docker in your project, then you need to take care of all this setup to run your code in machine. Tomorrow, if you want to run your project in another machine, then you need to set up all these things in that machine also. You need to set up all these things in that machine also to run your project. Okay. Now see, application stack, we already discussed that. Now application development. Now front-end components will be available, back-end components will be available, database components will be available, environment libraries will be available for our project. Our project is having some front-end components. Our project is having some back-end components. Our project is having some database and some environment libraries. Suppose if you are using Java, Spring Boot libraries are required, Spring libraries are required, Kafka libraries are required, cache libraries are required, JPA repository dependencies are required. Those are called environment libraries. Those are called as environment libraries. So as a DevOps engineer, we need to set up all this development stack: front-end components, back-end components, database components, and environment libraries. Whenever you set up all these components, is there any guarantee our project components are compatible with the machine that we are using? Some people, sometimes in one environment, I'm using a laptop, otherwise I'm using some desktop, or I'm using headless computers, some tabs. Okay, so when you are setting up all these dependencies, all this development stack for our project, that may not be compatible with all the machines. These are the challenges we are going to face. So when we face these challenges, then people will face issues like this. So now, development environment, in the development environment we are using in the development environment, we are using one machine. In the SIT environment, we are using in one machine. The code which is running in one machine, the same code is not working in another machine because of the version problem, because of the servers problem, because of database issues. A number of things will be available. A number of things will be available. So one is using Windows, other one is using Mac. You are using Java 1.8, they are using Java 11. You are using MongoDB 3.6, they are using MongoDB 4.2. So version conflicts are there. Version conflicts are there. So based on that environment, which operating system, which software, which server, we have to set up manually. You need to take care of that. So there is a chance of getting issues like this. There is a chance of getting issues like this. The code which is working in one computer, the same code is not working in another computer. The code which is working in one computer, the same code is not working in another computer. To resolve these problems, we are going to use containerization. To resolve these problems, we are going to use containerization. Docker is a containerization. Now, when you use the Docker, Docker will prepare its own platform to run your application. Docker will prepare its own platform. Now, I'm using my Windows machine. So Windows is my host operating system. In my laptop, Windows operating system is available. That is my host operating system. In this Windows operating system, I want to run my application. I don't want to set up all the softwares, Java, MySQL, database and all. I am not interested to set up all these things. Simply in my machine, I will install Docker. Docker is a containerization software. When I install Docker, that Docker will prepare a platform in my machine to run the application. Which application I want to run? For that application, Angular required. For that application, Java required, database required. So all the dependencies will be taken care by this Docker container. So in the host operating system, container we are going to install, that container will take care of all the softwares which are required. That is called containerization. Now, sir, what is this containerization? So Docker symbol is ship. Docker symbol is a ship. Do you know why they are giving it as a ship? Easily shippable. From one machine to another machine, your project can be transferred easily. The front-end components, the back-end components, the database components, the libraries which are required for the project, everything we are packaging as a container. That a container we can run in any computer. So that's why with the proper meaning, they have kept that ship symbol for the Docker. That means shippable. Easily we can transfer from one place to another place. In order to run my project in the dev environment, along with the code, I need some dependencies. In order to run my code, in order to run my code, in order to run my project, along with the code, I need some dependencies. Along with the code, I need some dependencies. These dependencies, you no need to take care. Docker will take care of everything. Your application code, your application dependencies will be packaged into a container. That container you can run in any computer without bothering about the dependencies. Whatever the dependencies are required for your project, Docker will take care of that. So you just write the code and you tell to Docker run your code, Docker will take care of that setup. Docker will take care of that setup. So that's why Docker is called containerization platform. What is the meaning of containerization platform? Application code plus dependencies will be packaged into one container. That container you can run in any computer, whether it is a Windows computer, whether it is a Mac computer, whether it is a Linux computer, you no need to bother. Docker will understand how to prepare the platform. Docker will give you that platform to run your code. So here container nothing but it is a package of code plus dependencies. Application code plus application dependencies will be packaged, and we are going to run that container in any computer, and a Docker container will work in all the computers. Easily we can run our application in any machine, in any environment, without spending much time for the dependencies configuration. Now, if I have 10 environments for my project, if I have 10 environments for my project, do I need to bother about the configurations, the softwares that are required for 10 environments? So if you go for life without Docker, life without Docker. So if you are not using Docker in your project, then you are responsible to take care of all these things. If you are not using Docker, then you need to prepare the environments and you need to take care of the setup of the dependencies to run your code. Suppose if I am using Docker, if I am using Docker, do I need to take care of these things? Not required. What I will do, I will use Docker container. I will use my Docker container. So if I have a Docker container, what will be there in the Docker container? Our application code, source code will be available. Application code will be available. Along with the application code, dependencies also will be available in this. Dependencies. What are the things that are required? So now code plus dependencies will be available in the container. This container I can run in the dev environment. This container I can run in the sit environment. This container I can run in the UAT. This container I can run in the pre-prod. This container I can run in the prod. Do I need to bother about the dependencies now? Do I need to bother about the dependencies now? The container which is working in one computer, that container can work in any computer. You no need to bother about environmental issues. You no need to worry. In this sit environment, which version of Java available? In the UAT, which version of Java available? Which version of MySQL available? Which version of Angular is available? You no need to bother about that because the dependencies will be taken care by Docker. Once you have a Docker container, easily you can run your Docker container in any machine. So the number of issues are going to reduce. The environmental issues will not be there when you go for a Docker. If Docker is not available, dev environment, you need to install all the softwares. Sit environment, you need to install all the softwares. UAT, you need to install all the softwares. Pre-prod, install everything. Prod, install everything, then run it. Maybe compatibility. So here in the sit environment, Ubuntu 22 point version is available. In the UAT, Ubuntu 20 version is available. The Linux operating system versions may be different. Java versions may be different. MySQL versions may be different. All the compatibility issues we need to take care. The code which is working in one environment, same code not working in another environment because of the version problems, version compatibility. So all these kind of environmental issues we can resolve by using Docker. So with the help of Docker, we are going to package our application code, application dependencies, and we will run that Docker container in any computer without bothering about underlying dependencies. Docker will prepare its own platform to run the application in any computer. If your application is running in one computer with the Docker container, that container can run in any computer. You no need to bother about the dependencies. Docker is going to take care of those dependencies. All right. Now, this Docker is required only for DevOps people, or it is required for developers also? Who will use this Docker? Only DevOps people will use this Docker, or developers also will use this Docker? Both DevOps people and developers should know how to work with the Docker. Docker is important for whole team, not only for the DevOps. Even developers also should know how to work with this Docker. Are you guys clear with the introduction part of the Docker? Just for introduction, it took almost 1 hour 40 minutes just to understand what is Docker. I did not enter into Docker, just I have given introduction, trailer for the Docker, theoretically. समझ में आया? Why we are learning Docker? समझ में आया? Why we are learning Docker? Just introduction took 45 minutes. Docker is a containerization platform. So what is the advantage of going for the Docker? What is the advantage of going for the Docker? We can package our application dependencies as a container. That container we can run in any computer. That container we can run in any computer. Easily we can build, we can deploy our application as a Docker container. So tomorrow, if a client asked you to set up one more environment for the project, do you need to bother about all the softwares that are required? If a client asked you to set up, if client asked you to set up one more environment to run the project, how much time it will take? Just take one virtual machine and run the Docker container. Take one virtual machine and run the Docker container. That's it. That's it. Now, running the application in the multiple environments, deploying the application in the multiple environments is easy or difficult with Docker? Running the application in the multiple environments is easy or difficult? Running our application in multiple environments is easy or it is difficult? If you don't have a Docker, it is difficult to run your application in the multiple environments. If you don't have a Docker, it is difficult to run your application in the multiple environments because you need to take care of all the dependencies. If you go for a Docker will take care of these things. Docker will take care of these things to run your application. Docker will take care of these things to run your application. So why the Docker symbol is a ship? Why they have given ship symbol for the Docker? Easily we can transfer from one place to another place. Easy to ship, portable. Our Docker applications are portable. Easily we can run our application in multiple machines. Docker containers we can move easily from one machine to another machine. Applications can be run in multiple machines without bothering about the underlying machine dependencies. Okay, guys, good. Now, so with this we understood what is a container. Container nothing but a package. So that package contains application code and application dependencies. Okay, so when I use a Docker container, I will run the Docker container in all the computers. Everybody saying that working for me, working for me, working for me. Earlier they said that it is working in my computer. I'm saying that it is working in my computer. They're saying that it is not working in their computer. But when I use a Docker container, application dependencies, code plus dependencies packaged as a container, that a container I am running in multiple computers, everybody saying that project is working because dependencies will be taken care by Docker. Dependencies will be taken care by Docker. Docker is what? Docker is a platform for packaging, deploying, and running our applications. So Docker is a platform which is used to package, deploy, and run our application. So package means code plus dependencies. Code plus dependencies. Okay. Docker enables you to separate your applications from your infrastructure so you can deliver your software quickly. So Docker is a platform which is used for packaging, deploying, and running our applications. Docker is a platform for packaging, deploying, and running our applications. With the help of this Docker, we can decouple, we can separate our application and our system infrastructure so that we can run this Docker application in any machine without bothering about the infrastructure, without bothering about the underlying dependencies. Easily you can deliver your application to the client with this Docker container concept. All right. Docker packages your application into container. So whatever the application code you have and what are the dependencies that are required for your application code plus application dependencies will be packaged as a container. So now by taking this Docker methodology, we can easily ship, test and deploy code quickly. You can reduce the delay between writing the code and running it in the production. Whatever the code the developers are writing, quickly, immediately, you can run that code in the production because you no need to take care of any setup. The setup will be taken care by Docker. By taking advantage of Docker's methodologies for shipping, testing, and deploying code quickly, you can significantly reduce the delay between the writing code and running it in the production. For example, if the Docker is not available, whatever the code is done by the developer, you need to test that code in the dev, you need to test in the sit, you need to test in the UAT, you need to test in the pre-prod, you need to deploy in the prod. For deploying the code into these environments, you need to take care of the setup. But if you go for Docker, container will be available, application code, application dependencies will be packaged as a container. That a container we can run in any computer. So as we are using Docker containers, we can reduce the delay between writing the code and running it in the production. We can reduce the delay between writing the code and running it in the production because Docker will package everything which is required for project execution. So to execute a project, what is required? As I told you in the application stack, front-end components required, back-end components required, database is required. Front-end technology should be installed in the machine, back-end technology should be installed in the machine, database should be installed in the machine, developers will give the code, along with the code, along with these dependencies, we will run the website. So here, by using this Docker, we are packaging our code plus dependencies, that is a Docker container. That container you can run in any machine without bothering about the dependencies. So Docker is a platform which is used for packaging, deploying, and running our applications. Docker will enable, Docker will make sure, Docker will give the advantage to separate your code and your infrastructure. So by using this Docker, quickly we can run our application in the production environment. By using Docker, we can quickly run our application in the production environment. Now, let's come to Docker architecture. Sir, how this Docker will understand which softwares are required for my project, which version of Java required for my project, which version of database required for my project, which version of Angular required, which version of React required to run my project. Code means developer will write it. Code will be available in the GitHub. Code is available in the GitHub. Now I want to create a container. How this container will know? How this container will know which dependencies are required to run this project? In which operating system this project should run? In which version of Java this project should run? In which version of the Tomcat this project should run? In which version of the MySQL database it has to use? How the Docker will understand which dependencies are required for our project. Our project may be Java project, our project may be Python project, our project may be .NET, our project may be Node.js. How this Docker will understand what are the dependencies that are required for our project. That's where we need to understand Docker architecture. If you understand the Docker architecture, then you can understand how Docker will manage the dependencies for all the projects. And Docker is platform independent, guys. Docker is not only for Java. Docker can be used for any project. It can be a Python, it can be .NET, it can be Node.js, it can be Angular, it can be React, it can be a PHP, whatever it is. It can be a WordPress also. Docker can be used. Docker is free and Docker is platform independent. So what is this Docker architecture? When we are working with Docker, when we want to use Docker in our project, first we need to write Docker file. So if you see in the Java, we have a pom.xml for Maven project. So for Maven, we need to give some instructions, which dependencies Maven should download. So for Maven, we have a pom.xml. So in the Ansible, to manage the configuration, we are having a playbook. For a Terraform, to create the infrastructure using Terraform, we have HCL language. Terraform script file we have. So in the Terraform, we have a script file. In the Ansible, we have a playbook. In the Maven, we have a pom.xml. Similarly, in the Docker, we have a Docker file. In the Docker file, we need to write the instructions, which operating system should use, which version of Java it has to use, which version of the MySQL it has to use. So as a developer or as a DevOps engineer, we need to write the Docker file. That a Docker file nothing but set of instructions to prepare the platform to run our application, set of instructions to create our Docker container. So Docker container should be created with the code plus the dependencies. How the Docker will understand what are the dependencies? The dependencies we are going to configure in the Docker file. Docker file is input for the Docker software. How playbook is input for the Ansible, how pom.xml is input for the Maven, how script is input for the Terraform. Similarly for the Docker, Docker file is the input. In the Docker file, we are going to write the instructions. Once we create the Docker file, we need to build that Docker file. When you build the Docker file, it will create one Docker image. Docker image contains application code plus application dependencies. So in the Docker file, we will specify what is required to run this project. Docker file contains what is required to run this project. In the Docker file, instructions will be available. We will understand how to write that Docker file today. We will understand how to write the Docker file. So it is very easy. It is very easy. So we are going to write the Docker file. In the Docker file, instructions will be available to prepare the dependencies or to prepare the platform. So that a Docker file we are going to build. When we build the Docker file, it will create Docker image. So Docker image is nothing but a package which contains application code and application dependencies. Once you have the Docker image, we will run the Docker image. When we run the Docker image, Docker container will create. In that container, our application will be available. Docker file, Docker image, Docker container. This is the architecture of the Docker. So in the Docker file, we are going to specify, for example, let me show you. So here I have my Maven web application. In the Maven web application, I have a Docker file. If you go to this Docker file, there are some instructions. I am telling to the Docker, hey Docker, I need a Tomcat version to run this project. I need Tomcat server to run this project. In my project target folder, my war file is available. You take this war file from the target folder, you deploy into Tomcat web apps folder. That's it. Now this Docker will take care of the Tomcat server. This Docker will take care of war file deployment into Tomcat server. That's it. Now by using this Docker file, I can run my Java project in any computer. I no need to bother about Java. I no need to bother about a Tomcat. I no need to bother about the deployment because I created a Docker file. In the Docker file, I told that I need a Tomcat server to run this project. That Tomcat server have a web apps folder. You take the war file from this location, you deploy into web apps. That's it. Now my project is ready with the Docker file. If I run this Docker file, then I will get Docker image. I will get a Docker image. If I run the Docker image, then Docker container will create. So now here I want to run the Docker container in the dev environment. Then what I will do? I will take a Docker image. Using Docker image, I will run the Docker container. I will download the Docker image in the dev environment. I will run the image. When I run the image, container will create. Same project I want to run in the sit environment. I will download the Docker image. I will run the image. When I run the image, container will create. Inside the container, project will execute. Dependencies will be available. Same project I want to run in the UAT. I will download the Docker image. I will run the Docker image. Then container will create. In which machine you want to run your Docker container, in that machine you need to download the Docker image and you need to run the image. When you run the image, Docker container will create. Inside the container, application will be available. Application dependencies also will be available. Perfect. Now, who is going to prepare all the dependencies? Image will prepare or container will prepare? Container. When you run the image, container will create. Inside that container, application and application dependencies will be managed. So when you are talking about the Docker architecture, Docker file, Docker image, Docker container. Docker file contains the instructions to prepare the image. Image is nothing but a package, code plus dependencies. When you run the image, container will create. Inside that container, our application will run and our dependencies will be available in the container. Now, if I want to run my application in multiple computers, do I need to write the Docker file for every computer? Or one Docker file is sufficient? If I want to run my project in 10 computers, do I need to write 10 Docker files? One Docker file, one image. One Docker file, one image. So once you have the Docker image, that image you can download in the computer and you can run that image. When you run the image, what will happen? Container will be created. When you run the Docker image, Docker container will be created. That container will have our application and our application dependencies. Now, I want to run my project in all the environments. What is required to run the Docker container in all the environments? Docker image is required. Sir, where we are going to store the Docker images? To store the Docker images, there is a concept called Docker Hub. Docker registry is available. We can say Docker Hub. Docker Hub we can use, or in the AWS, there is a concept called ECR. Elastic Container Registry is available in the AWS, which is used to store our Docker images. What is this? So Elastic Container Registry, fully managed Docker Container Registry, share and deploy container softwares. Our Docker containers we can run using Docker images. The Docker images we can store in the AWS using ECR, Amazon Elastic Container Registry. This is provided by AWS. If you want to go for Docker registry, Docker itself provided a concept called Docker Hub. Docker itself provided a concept called Docker Hub. So whatever the Docker images are available, we can store the Docker Hub. What is the slogan of the Docker? Build and ship any application anywhere. Okay, whatever the Docker images I'm creating based on the Docker file, that Docker image I can store into Docker Hub. The image I can store into Docker Hub. I will show you how to create the account in the Docker Hub, how to create the account in the Docker Hub, and how to store the Docker images in the Docker Hub. You see, I have a image, Spring Boot REST API. 10 months back, I have stored my Docker image into Docker Hub. All the previous batch students downloaded my image. 50,000 plus downloads are there. So people downloaded my Docker image to run the application. My Docker image contains application code plus application dependencies. Java web application, Spring Boot application, Maven application, Spring Boot with MongoDB, Spring Boot with MySQL. There are so many images I have created and I stored those images into Docker Hub. Now, if you want to run the Spring Boot application, you can take my image and you can run it. Code plus dependencies are available. You just need to download this image and you need to create a container. Okay, based on the Docker file, we are creating an image, that is file building. When you build the Docker file, Docker image will create. When the Docker image is created, then you can run the image. When you run the image, Docker container will create. So now we need to understand how to create the Docker file, how to create the image, how to create the container. That's it. I hope you got the clarity on Docker and Docker architecture. Docker is a containerization platform which is used to package our application and application dependencies. To create the containers, we need image. To create the image, we need Docker file. Docker file contains a set of instructions. Samjha? All of you got the clarity. What is Docker and what is Docker architecture? In which computer you want to run your application, in that computer you download the image and you run the image. Then container will create. I will show you. First, we need to set up the Docker. We will take a break now. After the break, we are going to see how to install the Docker in the Linux machine and how to create the images, how to run the images. that I will show you. Okay, guys. Are you clear with the introduction part? Docker is a containerization platform. Application code plus application dependencies will be packaged. Front-end components, back-end components, database components, everything we need to install manually if the Docker is not available in your project. So dependencies installation is difficult and error prone. There is a chance of getting issues with the environments. Environmental issues. The code which is running in one environment may not run in another environment. Such kind of problems will come. To avoid those problems, we are using Docker as a containerization platform. Life with Docker. Code plus dependencies will be packaged and it will be packaged as an image. That image we can run in any machine. Containers we can create. Container will have the application and application dependencies. So this is architecture. Docker file, Docker image, Docker container. This image we can store into Docker Hub or you can store into ECR. Once I create the image, I can use that image at any point of time in future. If the image is ready, that means code is available, dependencies are available. You can run that image in any computer. So how to create the images, how to write the Docker files, how to run the containers, that we will discuss in the next session after the break. All right. Perfect. So the people who are interested to attend this Docker workshop, so this is our institute WhatsApp number. You can send a WhatsApp message 9985396677. So this is our institute WhatsApp number. You can call them or you can send a WhatsApp message to them. So they will give you the details to attend the next session after the break. So the people who are attending only this Docker and Kubernetes class, so you need to complete your enrollment process. So this is our admin contact number. They will give the details. After the break, new Zoom link will be sent for the enrolled people to attend the next session. And the DevOps people, 03 DevOps people and my JRTP students can attend this Docker. You will get the link. Anybody who is interested to attend the Docker, who are attending this workshop for first time, you need to complete your enrollment process to attend the next session. So this is our institute contact number for the details. Thank you guys. So we are taking a break now. So it is 10 o'clock. I will start the class again at 10:20. I will start the session again at 10:20. So 20 minutes break. So have your breakfast and we'll start at 10:20. Okay. Thank you guys. People who are watching from YouTube, so you can contact our admin team in the WhatsApp. They will give the details to get the link to attend the next session. Thank you. Bye bye. People who are watching from YouTube, please like this